Welcome to Iron Disciples. We are continuing our fat loss, weight loss episode here with fats. Quick recap: we went over, and this has been the what we're trying to accomplish here is put a frame on fat loss, a historical frame, and give you guys an idea for where we stand today historically, and then give you an idea for the building blocks that make up our nutrients. So we went over carbohydrates last time, went over sugars, how they're created, how they're bonded together in polysaccharides, disaccharides, monosaccharides, and how we digest. And we remove these chemical bonds from the sugars to make them bioavailable, and then how it's stored as glycogen, which is a polysaccharide. And then it's removed again, those bonds, once they're in the muscle, as glycogen. So this is kind of the way that we're going through, not glycogen, but let's see one.
Glucagon? No.
Glucose, people. Lots of glues and glycose going on here. So anyways, today we're going over the third micronutrient, or the second micronutrient, sorry, that is fats. Okay? Big deal here, guys. So, fats. These are made of carbon, hydrogen, oxygen, and they are the most calorically dense of the micronutrients, coming in at 9 calories per gram, and is essential for making hormones, metabolic function, and breaking down of lipophilic molecules. Lipophilic means fat-loving. Philic means love. Lipo is fat. And absorbing fat-soluble vitamins such as A, D, E, and K. So those vitamins that I just said, A, D, E, and K, you cannot absorb them without fat. So don't take them with water. Take them with fat. We'll go over some of these little tips and tricks for vitamins and supplement use as well. So we have essential fats. Essential fats are fats that you cannot create in your own body, meaning you have to take them exogenously. You have to find them in nature, and you have to bring them into your system. That's why they're called essential, because without them, we die. Okay? These are omega-3s, 6, 7s, and 9s. Okay? Now, within each one of these 3s, 6, 7, 9, these numbers, they actually have 12. There's a 12 as well. These are like buckets, like a bucket. Okay? You hear omega-3s, 3s, meaning multiple. Okay? Omega-6s, multiple. So each of these buckets have what we call fatty acids inside of them. Okay, there's multiple types of omega-3s that fall in that 19 to 20 carbon chain. Okay, and there's multiple of the 6s. It's the amount of carbons before the fatty acid. That's what the 6, 7, 9, 3s are telling you. Okay, so just so you have in your mind, when you hear people talking about omega-6s, omega-3s are good for you, well, it depends on which fatty acid they're specifically talking about. It's a very general term. And we're going to get into this because we have a high point, which Mike brought up last time, which is the seed oil debate, which is a big deal. It's become almost borderline religious for some people, and they demonize seed oils. And we're going to talk about that. We're going to explain to you what's really going on, so you don't have to get your panties in a twist anymore over this discussions. You will have the firepower and the knowledge on your side. Okay. Let's go over the types of fats here. Mikey boy, tell us about it.
Unsaturated fats, polyunsaturated and monounsaturated. And polyunsaturated fat is a double carbon bonded chain, commonly referred to as a polyunsaturated fat, PUFA, PUFA are a group of fats consisting of omega-6 and omega-3s. Fats which both come from plants and animals. Omega-3, the alpha of the omegas. There are 3 kinds of omega-3 fatty acids: ALA, found in flax oil and some other seed oils and nuts, and EPA and DHA, found in fish. Grass-fed dairy meat also contain some omega-3 fat.
That's right.
Vegetarian sources of EPA and DHA are algae and some wild green plants like purslane. Purslane?
Yep.
Kinds of omega-3 fatty acids. The EPA, I'm not going to try that word.
Ecosapientaonic. And that's why they say EPA, because it's a mouthful.
found in a high concentration in found in high concentrations in salmon, jack mackerel, sardines, and other cold water fish. The fish themselves do not produce EPA. It is synthesis by microalgae, which krill eat, than fish. This is why wild caught fish will contain more omega 3s than farm raised fish. DHA, if you want to go for the real word,
Docosahexaenoic acid.
here we go.
Another one. It's kind of sexier.
Also found in high concentrations in salmon, jack mackerel, sardines, and other cold water fish. It is also found in walnuts, pecans, flax seeds, chia seeds, and many other nuts. And then alpha linoleic acid, ALA, found in high concentrations in flaxseed, canola, soybeans, tofu, walnut oil. Out of the omega-3 fatty acids, EPA and DHA are the fan favorites because they improve blood vessel functions, increase insulin sensitivity, and lower inflammation. They are also linked to better mood, improved appetite regulation, leading to fat loss. And high doses of omega-3, 10 plus grams, has qualities of blood thinning or the reducing of stickiness of the blood, enhancing blood flow and lowering blood pressure. EPA and DHA should be consumed in a 1-to-1 ratio to omega-6. Notice I didn't include ALA. That is because most people are sufficient in it from consuming foods made with canola oil, soybean oil, tofu, and all kinds of nuts. Most people's ratio is upward of 15-to-1 omega-3 or omega-6 to omega-3. The
Eicosanoids.
Eicosanoids built with EPA and DHA are superior to any other omega fatty acids. Eicosanoids are signaling molecules that regulate almost every function in the body and effect. This is why I recommend supplementing it unless you eat a lot of salmon or jack mackerel.
Very good, Mike. So I want to go over a couple things here before we get into omega-6s. First of all, is let's take head on the seed oil debate, because this is where we're headed with the omega-6s. Okay? So seed oils have been demonized because they create inflammation in the body, right? Now, as I said earlier, omega-6s, omega-3s, omega-7s, omega-9s, omega-12s, these are buckets from multiple fatty acids. They live inside of there, okay? Now, there's one particular fatty acid that lives in omega-6, which is the problem. And it's only the problem because we consume far too much of it. It's not a problem in itself. And that's linolenic acid. Linolenic acid by itself is not a bad thing. In fact, it's good for your joints. It's good for certain connective tissues. It's beneficial. But when you consume an insane buttload of this, like we do, because it's the most, it's in all of our seed oils. And when we say seed oils, what we're actually saying is this is the majority of the oil and the fats that we eat. That's what people are saying. We eat mostly seed oils. Therefore, we will have a lot of linolenic acid entering our bodies, which in turn is not good.
Well, isn't the big part of the argument is like that's a brand new concept. We weren't milking peanuts and other oils out of nuts before. Like, this is unnatural. Like, that's the arguments I'm hearing.
And part of that's true. A lot of that's true. And we generally used saturated fats for all our oils.
Yeah. Well, what I noticed about that argument is they normally don't include coconut oil or olive oil in it. And I'm like, I don't think we were milking olives back then either.
No, and that's a great point. And the difference between, say, olive oil and like a seed oil is that olive oil is much higher in omega-7s and 9s, right? Oleic acid, for instance. These oils do much better in your body, and we don't consume the amount of them that we do as linolenic acid than linolenic acid does. We've generally haven't ever historically had the amount of linolenic acid that we have in our bodies. And at such a ratio, and this is the ratio, guys. This is the important part for you guys to understand. It's a ratio, all right? So what I like to do is say, this is your omega-6 ratio. This is going to be even keeled between omega-3s. This is the best ratio, is a 1-to-1 ratio of omega-3s to omega-6s. If you can do that, right? It's better to have more omega-3s and omega-6s, okay? They compete, all right? And this is why omega-3s do so well in your body, because of the eicosanoids, which we had spoken about earlier. Now, cells are little balls, right? They contain information. They contain things. When I meant information, it's what I mean nutrients, right? They do all kinds of actions. They have to rub around against each other. They're always in friction. They're coming inside of cell walls and barriers, in and out of intestines, through muscles, through veins. I mean, they're moving around. So they have a membrane that surrounds them, right? And it's literally kind of like the bearings in your car tires. Like they're surrounded by a fat and that fat, when it's made out of EPA, changes the way that the DNA is expressed. Okay. Think about it like a door. Okay. The cell wall is the door in and out. So the genetic material changes as it goes, as that door changes, what comes in and out. All right. There's a big old door. A lot of stuff comes out. If it's a smaller door, only a little bit comes out, right? The shape of the door is going to tell you what can come out, what can't come out. Okay. So it changes the way the genes are expressed when you have EPA as your main fat source for your cell membrane, right? And that changes your body's inflammatory response. So today's world, we live in a world full of toxins. Free radicals are everywhere. We've never had more pollution and weird shit going on, for lack of a better term, that is in our environment than ever before historically. Our immune systems are like high alert, which is why there's a lot of people that have autoimmune dysfunction, because everything is the enemy all the time. This can put you in a downward spiral, right? Because then it starts going, everything's an enemy, everything. Let's start attacking ourselves. Let's start attacking our muscles, our hair. We start to get inflammation. We start to get psoriasis. We start to have, ulcerative colitis. We start to have Crohn's disease. We start to have brain fog. Our brains don't work as well. This can spiral out because our body's attacking everything, because it has a legitimate reason to do it. It's not like it's just going off the rails for no reason. But what happens is when you have EPA in the mix, it sort of tones everything down. The cytokines, these inflammatory responses that normally happen, they're kind of toned down because of the way that they're expressed. So this is how EPA can bring down inflammation, get rid of your brain fog. It actually will help with a lot of these autoimmune functions, because it's suppressing, in a way, it is actually suppressing your inflammatory response. In essence, it's giving your immune system like a bit of a break. So that's the way it works for inflammation. And that's why it's so powerful. That's why we love omega-3s. Let's get into some omega-6s right now. David, you want to check this one?
Sure. Omega-6s. So most of our omega-6s in the Western diet comes from eating seed oils, but it can also be found in seeds and nuts and dairy. Go figure. Kinds of omega-6 fatty acids, 3 of the 11. Linolenic acid, LA, the most common omega-6 found in seed oils, is therefore it is overly consumed and has been linked to chronic disease and inflammation. Arachidonic, is that how you do it?
Okay.
Acid, AA, is common in peanut oil. Gamma linolenic acid is common in seeds and seed oils. Omega-6, specifically linolenic acid, the most consumed omega, because it is found in high concentrations in seed oils like soybean, sunflower, safflower, canola, corn, cottonseed, and other vegetable oils. The primary fatty acid found in omega-6 is linolenic acid. When consumed in excess, can lead to a host of different issues due to chronic inflammation. Linolenic acid is not inherently bad and has great effects on joints and connective tissues, but it should be consumed in an even ratio to omega-3, specifically DHA and EPA. One important note to remember is that omegas are not very stable and are highly degradable. They will quickly turn rancid through the process of oxygenation or heat. That's why it's a bad idea to cook or fry with seed oils high in omega-6. Make sure your omega-3 is fresh. Otherwise, you will be doing it more harm than good, introducing toxic free radicals into your body. You can do this by tasting it. If it tastes bitter or rancid, throw it out.
So here's a quick answer to, as you might be asking yourself, so why do they turn rancid? What's the difference here between these omegas? Why are they going rancid under heat and oxygenation? What's the reason for that? It's a good question. These are double chain carbon fatty acids. So think about a chain, and within a polyunsat like omega 3s, there's two. Okay. Omega 6s, there's one. Now, when you apply heat, those little they fall apart. They start to come apart. Now, with the saturated acid, it's a single block. It's just straight ahead, right? It's like a straight line. And that's why it's solid at room temperature. Like these chains of saturated acid, they can actually stack on each other real easy. And that's why when it's at room temperature, it's no problem assimilating. That's why polyunsaturated fats, they don't assimilate like this. They have these chains, they're all like bent up and they're kind of wonked out because they have these either a double or a single chain in them, and they don't stack up, making them fluid at room temperature, but also making them prone to degrade under temperature or oxygenation. Those bonds are not super strong.
The one thing I was reading or listening to kind of look into some counter arguments to the seed oils, and like as far as the inflammation cause, like it seems like it's just the overconsumption. Like I want to kind of make that clear, because I think people are just saying like, oh, seed oil bad, and it's like, no, it's the overconsumption. Because the study like Lane Norton was talking about was like they were calorie for calorie flipping seed oils in for like animal fats or something in like some randomized controlled trial studies, and like it didn't, for a calorie didn't affect inflammation on the outcome. So if it's like in a reasonable amount, it doesn't seem like it actually has an effect. I think the problem is it's in an unreasonable amount. And I'm kind of curious, like if you sat and drank a bottle of fish oil like multiple times a day, would the overconsumption of that lead to similar effects as we're claiming about seed oils?
Yeah, it's the way that good question, Mike, by the way. So first, let's go over the ratio one more time. It is absolutely an overconsumption problem, and specifically it's linolenic acid. There are other omega-6s like arachidonic acid and some of these gamma-linolenic, which don't have the same effect, but it's just also because it's not as prevalent. Like linolenic is at the top of the list, and we have a little diagram down there you can kind of scroll to, which shows you just the way that most of the fats are broken down. It tends to be at the highest end of most of the seed oils. You're getting mostly linolenic acid in there, and it's really hard to not consume a lot of it if you're using a lot of seed oils for everything that you do, which most people do. It's in our salad dressings, it's in what a lot of people cook with, it's in all the processed foods that are out there. So it's going to be the one that's consumed on a high level. And linolenic acid, when consumed on a high level, is not good for your body. Because remember how I brought up earlier how EPA does different for your inflammatory response? How that open and the shape of the door, the cell membrane, right? It changes the way your genes are expressed, right? Your cytokines, these inflammatory, they're proteins, and they say, hey, something's inflamed, something's wrong here, right? Those little proteins are changed when we eat different types of fats. So if you have a high linolenic acid diet, your proteins and the way that your cells express the genes are going to make through those proteins to be firing off way more inflammation over the body. So it's like it's not a direct effect, but it is an effect of the way that your genes are expressed and the way that inflammation is then presented to those proteins, which are firing off constantly. So
I was kind of thinking like early man, were they getting exposed to much monosaturated stuff or polyunsaturated? They probably weren't.
Well, yeah. I mean, they were eating fish. So
depending on where they lived,
fish and seafood, absolutely. If, like I said, it is present in some grass-fed ruminating animals, and so is CLA. And mostly what we're talking about is long chain fats. It's kind of similar to what we were talking about with carbohydrates. The longer the chain, generally the better it is, kind of in
Mhm.
some ways for digestion. Sort of take a correlative to the fats. The longer the chain, like all omega-3s, those are two bonds, two chains in that. Okay,
Mhm.
omega-6s is one. Okay, and then it's almost like that's telling you something. The complexity of the fats telling you something there. So yeah, ruminating animals had it, and that's pretty much what we ate back then. I'm sure some guys had access to a lot of salmon, and they were very high in EPA. So we've had a lot of experience with that historically.
Yeah, it depends where they live, I guess. So now we're down to saturated fats.
Mm-hmm.
Solid chain of carbons, therefore it stacks nicely, making it a solid at room temperature, like Joe said. Unlike chain fats, comes from animals. It is used to synthesize hormones in the body like testosterone, protect the membranes of your mitochondria, protecting your DNA, and is claimed to be the devil because it can increase your LDL and is therefore unjustifiably classified as an unhealthy fat. As I have been hinting through this paper, foods that we have been consuming historically are generally a safe bet, but too much of these is not a good idea. Duh. It is the best fat to cook or fry with because it will not degrade at high temperatures.
And that's to all my, keto bros and to all my carnivore bros who are like, eating sticks of butter and eating pounds of bacon every day. This type of thing is not good for you either. Okay. It's no better than eating a bunch of linolenic acid. Okay. So just want to make that clear, guys. It's not the devil, but it's certainly not your savior either. So put away the sticks of butter and the pounds of bacon. It's not good for you.
How did the vegans get any saturated fat?
Oh, well, some of them eat a little bit of butter, but vegans, I will tell you right
I
now.
guess it looks like coconut oil is saturated.
Coconut's good. Some palm oils, like some of the hemp seed oil, flaxseed, you can get some omegas in there, but you're not going to get a lot of EPH, DHA through EPA, DHA. Keep saying that. You're not going to get a lot of that in there. It's not going to happen. You're not going to get a lot of B vitamins, and you're not going to get a lot of folic acid, and you're not going to get a lot of stuff when you're vegan. That's a whole nother conversation.
No creatine, no taurine, no.
Yeah, no amino acids. 20 amino acids that are found in your body are generally mostly only found in animal products. So you're going to have to try real hard to find them in plants.
Monosaturated fat, a single carbon bonded chain, comes primarily from plants. Avocados, olives, nuts, and some seeds contain monosaturated fats. Omega-7 palmitoleic acid and omega-9 oleic fatty acid are monosaturated fats. Everyone agrees that these fats are good. They increase glycemic control, good for diabetes, lower triglycerides, which is good for the heart, and may have anti-cancer effects that lower inflammation.
And those are only two examples, guys. Like I said, the omega-9, 7s, there's a few of them. These are the omega-7s, omega-9s, all these when we're referencing like oleic acid, EPA, DHA, those are fatty acids. Okay, guys. So when you hear people talking about fats and you hear fatty acids, it's a generalization when you say fats. When you say a fatty acid, you're specifically talking about a specific fatty acid chain.
Don't cook with these unless drizzling over salad. No heat unless you enjoy toxic rancid free radicals in your body. Hydrogenated fat is a man-made trans fat that is produced when hydrogen atom is added to an omega-6 polyunsaturated fat. These fats are solid at room temperature. Think Crisco or margarine. These fats are not easily metabolized and stay in your bloodstream, oxidizing and contributing to an increased risk of heart disease, diabetes, and cancer. It is also linked to brain deterioration, Alzheimer's, depression, obesity, and bodily disease and pain due to inflammation.
Sounds like a safe bet.
Sounds like a good time. Natural trans fat is produced in the digestion process of animals that chew cud or ruminating animals. This comes from the bacteria in these animals' extensive digestive tract. Some have multiple stomachs to ferment and extract the most nutrient from low nutrient vegetation foods. An example is a conjugated linoleic acid,
Good job,
which is present in dairy from pasture-raised animals. CLA has a number of health benefits, including anti-cancer, improved immune system or immune function, enhanced insulin sensitivity, promotes glucose tolerance, and decreased inflammation. It also stimulates uncoupling protein genes with raised body temperature, thermogenesis, which burns calories, aiding in weight loss. Triglycerides are 3 fatty acids connected to a glycerol backbone through dehydration. This is how the body stores fat, similar to how we store sugars in the form of glycogen, which many glucose molecules attach together. Triglycerides can be composed of different fatty acids.
So right here, we're going to get into your blood work. Okay, so when you eat fats, they come in all different forms. You got triglycerides, you got cholesterol, and these fats go in through your digestion. All right, you break them up in your mouth, you masticate. There's a lipase, which is the enzyme. Lipase digests fat, and then it goes down. Now, you ever heard of your gallbladder? Okay, your gallbladder's got an important function. Mainly, what it does is it releases bile and acids. Or
Dave
salts.
doesn't have that.
You don't have that.
I don't have a gallbladder, no.
Right. So digesting fats for you is a little bit tougher.
Mhm.
So you don't have bile. Bile is just kind of like the dawn.
Well, I do have bile. The liver produces bile. I don't have a way to store it.
Liver produces some enzymes that help break down, but your bile is generally created in most of it anyways. The lion's share of it's your gallbladder. Then you have your bile salts, which come out, right? So bile goes in, it's kind of like dawn, and it separates like you would washing a dirty, greasy pan. It separates these larger clumps of cholesterol and these lipids, triglycerides, and it separates them. All right, just like the dawn does in your pan. And then it goes in there with the lipase. They separate them a little bit further, right? And then these nutrients, when they get in your small intestine, they're kind of shuttled off through the cell wall in your small intestine, and they are creating these different balls. All right. Now we hear about cholesterol. What is cholesterol, right? We hear about triglycerides. What is a triglyceride, right? They're both on your blood work. All right. And then you have HDL and you have LDL, right? Low density, high density. One's good, one's bad, right? We like our high density and we don't like our low density, right? Why? What is the difference? What's going on? What is our body doing with these fats? Are they the same thing? Why are there so many of them? Why is this so confusing? I'm going to make some clarity on this, okay? So your bloodstream circulates a few different kinds of fats, right? We like to talk about cholesterol. I like to make this an analogy of a truck, okay? Each of these trucks are different sizes. Some of them are little tiny Toyota Tacomas. Others are dumpster trucks, all right? And inside these are packages, right? Some of these packages are really tightly packed and they're very dense. That'd be like your HDL, high density, right? So when that fat comes out, it's digested, it's very loose. It's like a bunch of Christmas presents all on the table. And you're like, I got to put this all into one box, right? So they take all the presents, right, and they put them in a box. And it's not really packed very well because it's like your little sister that did it. And it's all like sort of out of control and sort of not very well spaced, right? So that would be like an LDL, right? And there's more. We're going to get into this in the actual cell, the how it scales up. But first, it's a chromolemacron, right? Which is very, very much like the Christmas presents all over the table. Then there's VLDL, which is very low density, which is more like she kind of put them together in a pile off to the corner. And then there's IDL, which is intermediate density, which is like her little brother came in and helped stack them up. And there's LDL, low density, which is like you finally got it into a box, right? But it's not great. And then there's HDL, tightly compact cartel cocaine style. Like that stuff, you could drop it off a boat. It's still going to float. It's going to make it to Miami.
Tetris
Someone's
Master.
making a bunch. Tetris Master, right? This thing is densely packed masterpiece, right? That's why we like it. That's why everyone's like, this is great. It's not going to cling to your cell walls when it's going through and cruising through your veins. It's less likely to get caught up and be formed as plaque, right? And the next question is why is there anything in your blood vessel that should be clinging to anything at all? But that's a different conversation. We'll get to that later, right? So now that you get this idea, these little trucks and these little packages have different types of fats in them. Triglycerides are the way we store fat, which is a glycol that is attached to 3 different fats, right? They could be anything. They could be polyunsaturated. They could be a saturated fat on there. They could be a monosaturated, any kind of combination of it that's in there. And there's different types of cholesterols, right? And on the outside of this cell, all right, there's a little fatty layer around that, which is a very special fat. It's a phospholipid, and that allows it to travel around. Okay. So this is what they mean by your blood work. And they look at the cholesterol, which are the trucks, and then what are they called? Okay, where are they? Scroll down, Mikey, real quick. Okay, scroll up. Triglycerides, right? So there's triglycerides and cholesterol. They're both cruising around your bloodstream, okay? And there's different sizes. So we measure our cholesterol and we measure our triglycerides, right? So what happens when you take a lot of EPA? For instance, me. I'll give you a little insight to my blood work, okay? I oftentimes get back high LDL, right? Which is low density. And then a doctor will look at them and be like, you have a lot of LDL in your blood. I'm like, yeah, but look at my triglycerides. Now, triglycerides have been taking over as the main determining within cardiac health, and for a good reason. It's a much better determining factor of that. My triglycerides are super low. All right. So if you have very low triglycerides and you have high LDL, that means you're taking in usually means you're having a lot of good fats in your diet. Okay. And LDL, like we have been saying, depending on how far your little brother got into packing it, it could be a lot closer to being packaged in a box than it is just spread out on the table. Okay. So they're not all the same. LDL is not all the same. And when they measure it, it's a very general scale of how they measure it. So you could be a whole lot more closer to HDL on that LDL factor than you are to LDL. Okay. It's a very good thing to realize if you are supplementing fish oil and you do come back with a high LDL score, but your triglycerides are low, this is a very good fact and you should not be scared of it.
I think that was one of Paul Saladino's big arguments because he was trying to basically call out the industry on cholesterol, saying like LDL is not a good determiner. The context of the high LDL is what matters. Like, are you in a unhealthy sedentary body that is inflamed and you got high LDL? Probably a bad thing. But if you are like fit, thin, on a carnivore diet like he was at the time, like your LDL is just going to be higher because of that diet. Is it actually building a plaque like the doctor is going to tell you it is? Mm-hmm. And it's a little bit out for, there's not a lot of data on it, but I think the theory is like it's a lot different.
Yeah. So if you think about like your blood vessels, they should be smooth running, like beautiful straight pipes. There's no rivets. There's no bolts on that shit. It's just a beautiful, smooth, like pipeline. It's God's creation. It's perfect. But then you add in inflammation, you add in like all the sugars that we eat, these terrible foods that are causing inflammation, not to mention just the toxicity of our environment. It's worse than it's ever been, ever. Forever chemicals, all types of stuff that's like lodged in our body. It's insane. But these blood vessels that we have, these smooth running, beautiful veins, are oftentimes filled with lesions. Now, these little lesions are inflammation spots, right? They're not smooth. And what happens is, when we're talking about the HDL being like a tight-knit cocaine, like just like this thing is just not going to get caught on anything, bro. You throw that thing off a boat, it's going to like, these are much less likely to get hung up on anything in the vein. They kind of bounce around. They're dense, bro. They're not going to get bounced up. Think about throwing a cotton ball versus throwing like a bowling ball. Like, which one's going to get caught on the baseboard? It's going to be the cotton ball, right? So that is the LDL. It's the low density cotton ball that gets caught. That bowling ball just bowls right on through all the lesions, all the inflammation, doesn't care. So it's not like it's good or bad. You should be asking the question that you're asking, Mike, is why are we inflamed? Why are the veins and the blood vessels have these lesions and have these places where fats can get hung up to begin with? That should be the question people are asking. So if you have super high cholesterol and you don't have inflammation, your veins are smooth. Fat's just running through it. Fat's, what do you lube your car up in your engine with, right? It promotes, movement. It's viscous. It makes things move. Smooth. That's the same reason why EPA makes your blood, quote, thinner. It doesn't make it thinner. What it does is it makes it less sticky. which is exactly what we want in our blood. We want it to be less sticky, we want it to run smoothly. So that's why we don't like LDL. It's because it gets hung up on inflamed arteries.
And definitely talk to your doctor about your blood numbers, and don't take our word as gospel on it, because we are not medical
I'm
doctors.
not a doctor. Don't take any of my word on any of this. Go out and do your own research and do deep dive and learn about this for
We're
yourself.
just keeping the lawyers off our back.
This is just recommendations. I am not a doctor. I am an idiot. Okay, so do not listen to
Just
me.
pause this episode now. Just delete.
Go listen to your doctor. But he is probably an idiot as well. So do your own research at the end of the day.
They're gonna want to sell you some statins, get that LDL down, and
Good news about
Just do
statins, it's a blockbuster drug, and it only has a 30 to 20% effectiveness. So good luck with that.
yeah. Where are we at here?
Cholesterol, kind of went over a lot of that stuff. Lipoproteins. Oh, yeah, that's a cool little diagram. Shows you the size. So those are those first size. Like I said, that's your little sister. The very to the left, you see your presents all on the table everywhere. Little sister comes around, she puts it in a pile. Brother comes around, makes it, stacks it up, gets in the box. Then you got your nice cocaine cartel, densely packed kilos right there that are making it to Miami Beach, live or die. Like that's the HDL right there. So it all has to do with density. You would think HDL, high density, would be bigger, but it's actually smaller. It's just denser. Cotton balls and baseballs. All right. That's a quick little rundown of digestion. Bile salts emulsify the fats and then broken down further by lipases, which is an enzyme, fellers. Absorbed by intestine, then put in the lymph and the bloodstream, stored in the body, stored in the liver. All right, Dave, which fats to eat? Tell me.
Which fats to eat? That is dependent on what you are using them for. If you're cooking using saturated fat like tallow, lard, ghee, or butter. If your salad needs fats, use olive oil or avocado oil. Try and match your omega-6 fat consumption to an equal amount of omega-3 fats. In other words, a 1-to-1 ratio. Omega-6 fats, predominantly linolenic acid, are found in high quantities in seed oils, which are the fats in most processed foods, which happens to be what most restaurants cook and fry in, and that's not great. They should be using a saturated fat like lard, ghee, or tallow. Everyone will need different amounts of fats. You must eat fats. You can live without carbs, but you will die without fats. The amount of fat you eat will be determined by your genetics. Some will take more, others less. Fats should make up anywhere from 15 to 35% of your calories.
So let's do a quick recap, guys. Why are fats important? First of all, your hormones are made off of them. We all like testosterone, melatonin. We like estrogen. We need progesterone. Okay, we need DHEA. All these things come from fats. That's where they come from. All right. We have fat-soluble vitamins, A, D, E, K. Those vitamins will not be metabolized unless you have a fat present. So if you take your A, your D, your K, and you're on an empty stomach, you're not going to metabolize those vitamins. They are lipophilic, meaning they like fat. Okay. So what are the next things? We have different kinds of fats. Omega-3s, omega-6s, these family of omegas that you hear. These are buckets. They're buckets and generalizations for specific fatty acids. Some are better than others. We tend to like the DHA and the EPA. Very great for reducing inflammation, increasing metabolism, brain function. They take down inflammation in your body in a profound way and change gene expression. We also have the omega-6, omega-3 discussion, seed oil discussion. The main devil, and it's not a devil, it's just because we consume too much of it, is linolenic acid. It's one omega-6 fatty acid, one particular one. Okay, these are essential fatty acids. These are ones that you do not make in your body. You must supplement them, get them exogenously. That's why they're called essential. Okay, then we went over the saturated fats, how they stack up evenly. And that's why they're solid at room temperature. Those are good for cooking with. All right, they don't degrade over heat. like your omegas do, they are less complex. The chains that are not there in omegas are not there in saturated. Excuse me. Okay, we go further into your blood work. We have triglycerides. We have cholesterol. Okay, look at your triglycerides, people. If you want to get a great reading on a better reading to understand what your cardiac health is going to be like, since that seems to be why people use those. Look at where your triglycerides are at, and try not to cook with seed oils or anything that's omega. They tend to break down, become rancid. So if you want to use them, it's fine, but make sure that they're an even ratio to your omega 3s, specifically EPA and DHA, so that your ratio is most optimally a 1-to-1 ratio EPA, DHA to linolenic acid specifically. Okay, guys, that might be tough for you all, but it's a good thing, even if you're getting close to it. Even if you're like a 6-to-1 or an 8-to-1, most people are at a 16-to-1 to a 20 to a 30-to-1, which is abysmal, horrible.
How about part of the conversation around like what is a fat versus and a carb versus a protein? Like fats and carbs are energy, protein's a building block. I think it'd be worth kind of touching on that, because I think like a good rule of thumb I've always heard is don't combine your energy sources. So if you're going to eat, eat some carbs with your protein or eat some fats with your protein. Don't eat a whole bunch of carbs and fats together with no protein. Does that kind of make sense?
Certain people might, and I've heard the whole like eat your carbs last or eat protein first or whatever. But generally, I think it's not that big of a deal.
Well, not necessarily the eating order, but like if you're making a meal that's literally pasta with a bunch of fats and oil and no protein, like you just ate a bunch of fuel source that's going to get stored, or versus having like some fats with some protein, just kind of like that different breakdown on the macronutrient. Because I don't think a lot of people realize that your body can either use carb or fats as an energy source.
Can also use protein. Protein. It takes a higher thermal index to create it, but can also use protein. But generally speaking, high fat, high carb is you're going into donut territory. If you find yourself in donut territory where you got high carbs, high fats, I don't care if it's pasta or if it's just outright sugar, sugar and fat. Like we're in a really not a great healthy territory. That's because it's just not natural for us.
Well, I think it's a lot of fast food, because if you think about it, you might get some chicken, a little bit of protein, but then it's all fried, breaded, and then you're having some fries that are fried with it, and then you're having a Coke with it. So you're basically high fat, high carb, little bit of protein.
Yeah.
So don't do
Noodles and Company, and you get like a bunch of pasta, and then you get like breadsticks and everything.
Butter.
Oh man, that's so good.
It's good. That's why people eat it. It's easy to eat. It's easy to eat. Cover it in butter and make it carbohydrates. It's like,
so yeah, don't do that.
Don't
just mix your fats and carbs like crazy.
I like to say this, and it's a good rule of thumb. Now, eating healthy is not easy. Doing what we've done for years, it's not easy. It's a big learning curve for a lot of people. It's just like getting a PhD for some. I mean, it takes just as much effort. There's just as much pain and suffering involved with changing your diet and getting a healthy, fit body as it is with getting a PhD in psychology or something, or biochemistry. It's not easy to do, okay? And it's different for everybody. But one thing that I will tell you is that eating a healthy diet, if you have for instance, like a typical meal for me would be like 300 grams of white rice for dinner and like 300 grams of like grilled chicken, and then maybe some cucumbers, and that'll be it. Now, if I am not hungry for that meal, it's because I've been eating like crap. You will be hungry for a good, clean meal if you are eating the right amount of calories. It will look like a donut to you. If you have been eating donuts, that meal will look not very appeasing to you. You'll be like, I'll eat a little bit of this, but it's a lot of food. The more quality of the food that you eat, like the nutrient-rich food, calorically not as dense, means you will have to eat more food. You're literally going to be chewing and sitting there eating more food. But if you can find yourself being hungry for good food, that means you're heading in the right direction. But if you need that donut and that glaze and that fat drizzle and all them sauces and the sugar and all that, you're not hungry enough to eat. I'm just telling you, you're not hungry enough to eat. You need to tone it down. You need to be ready to eat that, that simple food.
Yep.
I do have a quick question. You're talking about, cholesterol and plaque buildup and whatnot.
Yeah.
Is it possible, if someone does have a lot of plaque buildup or that's starting or whatever, can that be reversed? Can plaque be removed?
Is that what some of the meds do?
I don't know about some of the medication, but I do know that with certain lesions. So here's how it works out, David. It's like your blood vessel will have a lesion in it, right? It'll get wounded. And usually that'll heal up on its own. All right. It might take a little while, but it'll heal it up. But what happens if it doesn't heal up and it still keeps getting affected is your body will put in this scaffolding of calcium in there. And it's to fortify that blood vessel. It's that's calcium that it puts in there. That is going to cling to a lot of that low density fat. It starts to build plaque pretty quick, and it sort of insulates itself. So once it gets to that point, it's a lot harder to heal. And those chunks generally come off in bigger pieces, and they're harder to get rid of. But it is reversible. But you have to do it with diet. And I would say now we have some research on some peptides, which are regenerative, like GLP-1, which we're going to get into, which is a semaglutide, which is Ozempic, which is getting a lot of fanfare for being a fat loss tool, for mostly just fat loss. It was created for diabetic, but it's a peptide. It's not a drug, and it has a lot of regenerative qualities, and it's very good for cardiovascular regeneration. So they're actually thinking about using that in repairing vascular damage. So there are some progressive that are non-drugs that are happening in the field. Peptides are a really great place where I think we're going to see a lot of growth.
Isn't the technical term for the plaque buildup I can't even say the word
Asclerosis,
something like that.
Yes, not a good thing, but very prevalent. So yeah, it is reversible, like most things in the body. It can repair itself, but it takes diligence. So
yeah, I don't think it's maybe reversible. If anything, it's most likely just going to stop.
It would take a long time.
Yeah,
it's just like if you blow out a disc in your back, it's going to take you a couple years to repair that. So things are repairable. They're just not. Most people don't have the time to study a person for 3 years and see how their veins have gotten better. Not in America. It just doesn't happen very often, but it will. And your body does regenerate. Pretty much everything. They thought neurons didn't regenerate, but they do. So there's a lot of science coming out to support the regenerative qualities of the body, guys. Good news.
What's next time?
Next time, we're going to get into proteins, guys. It's going to be a lot of fun. Get into amino acids, the building blocks of proteins and peptides. You're going to start to understand how all that works together. Yeah, it's be science class. Once again, I'm not a doctor. Figure out this stuff for yourself. Get in there and get healthy and start enjoying feeling well for yourself.